Okay, well, let's go ahead and get started. My name is GarenEvans, and I'll be doing the first talk today. Economics is known as the dismal science.
Yes.
And there is a swaggering denizens of the underworld that make up econometrics that are really, it seems like it just overcomplicates things sometimes. There's numerous procedures and models and statistics that are used to explain all sorts of economic phenomena and help understand things like inflation and unemployment, why GDP goes up and down in recessions. So on the theoretical side, of course there's going to be a lot of theoretical things. There's going to be a lot of not necessarily application type things going on in economics. But econometrics is there to help us understand these things in a very formal and disciplined way. Well, fortunately at Dalton State, we don't focus so much on the theoretical side. We focus more on the applied side. And the course that I teach, which is applied econometrics, is just that. And while the syllabus says a lot of things, it basically just comes down to using statistical methods to help explain various economic relationships. The problem is that putting these statistical methods and combining them with theory is not an easy. It's really hard. And for students who haven't ever even heard the word econometrics, and maybe it's been a while since they've been in an economics class in the first place, this really is a challenge for them. And it's for several reasons. One, simply a comfort level with statistics. So most of my students come to my class and they had statistics maybe a year or two ago. And so they don't even really remember a lot of the statistics that they see. So when we start talking about p-values and confidence intervals, it just blows their minds up. They need a refresher. There's also a comfort level with new technology. Very often econometrics is taught using a completely different type of software package. Instead of using Excel, we tend to use things like Stata, SPSS, and I use R in my class. And these applications are not necessarily the easiest things to learn. One of my students told me, they said, you know, this is kind of like learning another language on top of learning the material. And then, of course, there's the problem with relevancy. We'd like to say, well, of course there's this relationship between unemployment and inflation. Doesn't everybody know that? Hasn't everybody heard of the Phillips curve before? And maybe even if you have, it just doesn't really seem like it's all that exciting or all that relevant to the things that you might be doing as a student. So one of the things that I'm doing in my classes now is to give them a project where they replicate an existing research article, something that's been published, something that's out there that they can find. And maybe maybe this is a fairly complicated article, they might not replicate the entire article, but maybe just a few of the key analyses within that paper. And then, of course, they report the results. This is what I tell them their project is. And this is how they look at me after. There's really quite a lot of concern in their faces. So what I've done, I've put together what I think of as a framework for doing this successfully. And it comes down to having them choose the paper that they're interested in working with. So it's got to be an interesting topic. And really, probably this number 4 should be at the top, because it has to be something that they are interested in. It needs to be in a published article, obviously. And one of the reviewers of the paper that I recently had published, their comment to me was, well, and it should also be an article that has not been retracted. Well, I really thought about that, but yeah, I suppose so. it should have some type of empirical content. And in econometrics, we spend a lot of time doing regression analysis, so it doesn't really make a lot of sense to just do a simple comparing one population mean to another. We need to have some type of a model that explains something else. And so that's the next hard part of the work. But the hardest part of all of this is really for the finding the data. This is not an easy thing for folks who are doing research, but for someone who's never done this at all, trying to find the data is really a challenge. But all of these things are great because they teach students how to find articles and find things that interest them, the problems of working with data, and hopefully they're doing all of this and staying motivated at the same time. This presentation isn't really about me, it's really about one of my students, whose project last year was to replicate this article, assessing the U.S. Senate vote on fuel economy standards in the United States. So they come out with one of these CAFE standards every year that says, cars should have a certain miles per gallon, trucks should have a certain miles per gallon. So she found this in the Journal of Statistics Education, which is a great journal because, for one thing, not only do they have the articles, but they also have the data available to them. So it's really good for them. Okay, so Preston, who originally wrote this article for the Journal of Statistics Education, submitted it to the journal for several reasons. One, he said that this demonstrates how useful the logistics regression method is. Now, you don't have to know what logistics regression is, but obviously this is a kind of some fancy words up here, so for a lot of students, when they see this, they are confused by that. So I was really impressed by my student to have the fortitude to continue on. That the analysis explains how senators vote, and that it quantifies the effects of ideology, whether you're a Republican or Democrat, on how you would vote, as well as how money affects how you vote. And the best part about this is that it confirms preconceptions that we have about positions. I asked Savannah to be here. She was my student last year, but she's out in the workforce now, and she couldn't get away from work today. But I thought I'd just put a couple of comments up here about how she felt this process went. And she chose a topic that was interesting. So she met that part of the goal. Part of this, she really had no experience doing anything like this. And in fact, she told me, she said, I really didn't think I could do something like this. And so she's also learning about the various, not only the models, but also the reasons why these phenomena are occurring. So now you're probably all wondering, what were the results? Well, there were two results. One is, she was able to replicate the results of the paper for the most part. She did discover, however, we both did, that she couldn't replicate every statistic. There were some things that were slightly off. Some things that just didn't seem right. And maybe it was a mistake of the original researcher, maybe it was mistakes that she made, maybe it was a difference in technology. We'll probably never know. In this diagram, it shows the level of donation. In the purple or blue there, that's the Democrats, and the red is the Republicans. And on the left-hand side, on the vertical axis, is the probability that they would vote yes on this CAFE standard. So, for example, on average, a Democrat who receives $100 in funds and donations, about a 15% probability they would vote yes on this measure. While Republicans, there was more than a 50% chance. That's how it is. The other result of this paper was that I told Savannah, I said, this is great work you've done. It really shows that you're my best student. And I wanted her to not only do this, but also extend it out and collaborate with me on a paper that we can publish talking about this variation, how to do replication research. And this was the result. So we submitted a paper to Sage Research Methods Cases. And the Sage Research Method Cases, for those of you who don't know, is really devoted to providing cases for our students to show them different ways of doing things in education. And so they accepted this after a revision, and we got this published online. And so that was a success. Thank you.
We have some extra time. We have time for a few questions.
I gotta run downstairs, but, you know, you're talking about this relative to econometrics, or however you pronounce that word. To me, it looks like it's something that can be easily generalized across any of the fields. I mean, if you're looking at replication research, I think that it gives faculty and students opportunities to look at other aspects. I mean, psychology could be doing it. I mean, I think that the real question is the data, getting access to the original data, and how that may stop things from happening. But I think it's an interesting idea. This student you said did this last year. Did they graduate?
They did, yes.
Where are they now?
I'm not really sure. I think they're working for local manufacturer at the stations.
Appreciate the information. What was interesting was if you notice those two lines, Democrats versus the Republican, once you got by $1 million, there wasn't very much separating them. So money buys votes, as they say.
I'm curious, when students choose the study they want to replicate, do they also have to consider that their access to the data? Do they have to choose the data?
That's the challenge. How do they get access to the data? So and I'll be happy to share the paper that we wrote that kind of provides a guideline and framework for doing this. But part of it is they communicate with me regularly on their progress. So one of the first assignments for them is to identify the paper, reproduce a couple of tables directly from the paper, and tell me whether they can get the data. So, and if they can't, sometimes I can help them with that. Like I'll send an email to an author and ask if we get the data. Sometimes it works, sometimes it doesn't. And sometimes they're using secondary data so they can get it. And furthermore, they could probably extend it with new data, and that could be absolutely new research all the way around, not just replication.
But in economics, y'all primarily use secondary data.
I wouldn't say primarily, but that's
More than 50% of the time.
That's the easiest data to use.
Okay, so, right.
Yeah, primary data would be collecting surveys.
Correct. Right. So if the big article is secondary data, you have to get based on a database.
I have a question about, so you said that you're using R with your students. How has that been? Are you using R because it's free, or because it can do so many things, or I'm just curious about your experience.
For both reasons. So,
Yeah.
So when I first started teaching econometrics here at Dalton State, I had looked into getting SPSS licenses or STAT or something like that, and they were too expensive. And I didn't know anything about R, so I taught myself R, and then I taught my students R. So
I think it's great. I'm struggling to stay across my research and analysis class, but I've come across a totally free software that's really similar to SPSS that's called Jamovi, and there's another one that's called JASP that can do some non-parametric things, but I love to talk about it after. Jamovi. J-A-M-O-V-I. And it's really similar to SPSS. Yeah.
Anybody else? Okay, well, I think we've got a few minutes before the next talk, so if you want to grab a cup of coffee, we'll be back here at 9:50.